The first self-playing piano system was invented around 1895. It sat in front of a regular piano, and the machine's wooden fingers would play the keys. Guiding those fingers was a roll of perforated paper. By the early 20th century, piano companies incorporated the roll mechanism right into the piano itself. The player piano rage petered out around 1930, but there are still plenty of old player pianos around, so there remains a market for the music rolls they play. The original roll-making method used a recording piano. As the musician played, each key would trigger a pneumatic valve which pressed a corresponding rod against piano roll paper over carbon paper. Then they just perforate the carbon marks. The modern method uses an electronic keyboard and a computer. As the musician plays, the computer converts the notes to data. The musician edits the data, then loads it into a computer that's hooked up to the roll perforator, a machine that produces 18 rolls simultaneously. Like the old recording machine, the roll perforator has a pneumatic valve for each note of the piano keyboard. As the computer activates each note, the corresponding valve triggers a steel punch to descend and pierce a hole in the passing paper. The longer the hole, the longer the note. Most music consists of multi-note chords, so the machine vibrates like crazy, punching many notes simultaneously. When the machine finishes perforating, the operator cuts off the paper and sticks on a temporary label bearing the song title. The paper then moves on to another area, where they permanently stamp on the title and other information. Here they slice the front end of the paper into a point. Meanwhile, this machine rivets brass eyelets onto an adhesive-backed polyethylene strip. Then around each eyelet, a die stamps out a tab. They stick one eyelet tab to the pointed tip of each roll. This tab end, as it's called, hooks into the mechanism of the player piano. A touch of cornstarch over any exposed adhesive prevents the papers from sticking to one another. When the music has lyrics, they print the words right on the rolls, so you can sing along as the piano plays. The first step is to make a lyric stencil, which requires cranking out each word letter by letter. The placement of words on the stencil is tricky because they have to synchronize with the notes. The stencil goes into a printer, which applies the lyrics with an ink roller. The last step is to roll up the rolls. They wind each one around a cardboard spool that has a plastic flange on each end. When you load a roll into the piano, you mount its flanges on holders, then hook the tab end to a spool that pulls the roll through the player mechanism. A rubber band to keep the roll from unraveling, then it's into a custom box. A machine shapes and hot glues sheets of ornately printed cardboard into the box tops. The finishing touch is a sticker with the title of the music. When a roll moves through a player piano, air flows through the perforations, triggering the corresponding pneumatic valves. Each valve pushes down the corresponding note. This factory produces more than 4,500 different song titles on player piano rolls, from classical favorites to top 10 hits. The first oil tanker was launched by the British in the latter part of the 19th century, and it fueled a revolution in transportation. These enormous ships now dominate the world's oceans. They move millions of tons of oil daily, and without them, most of the world's economies would be powerless. The life-size version of this tanker ship will be bigger than 2 football fields. It's so big that they build it in sections called grand blocks, which they assemble by crane in a dry dock. The process takes plenty of planning and engineering. They map out the job on a computer and assign a number to each of the 110,000 parts. In a big job like this, computer-coordinated labeling is the only way to go. They weld steel sheets to build the ship's hull. Sand placed on the seam melts during the welding to shield the seam from any contaminants in the air. Workers ready the structural steel beams. A robot places them at just the right spot on the welded section of the hull. Then an operator verifies that the placement is correct. More robots weld the beams to the hull section. Next, they submerge a steel plate in water. The water suppresses the noise and smoke from a plasma cutter as it carves holes in the steel. This steel plate will be part of the ballast tank. Some of the holes will allow water to flow through, while others lighten up the steel structure. The superheated plasma also cuts slits to interlock with the structural beams on the hull part. They then weld the assembly and install a top plate for a double-layered hull. Double hulls provide extra protection against oil spillage. After a paint job, powerful machinery transfers the double-hull grand block to its final position on the side of the tanker. When fully assembled, the hull will have 12 cargo tanks with a total capacity of 14 million gallons. The engine section is situated at the stern of the tanker. It will take 3 diesel generators to power the ship's lighting, ventilation, and computer systems. They carefully lower each one onto the deck of the ship. A 10,000 horsepower diesel engine will be the tanker's driving force. Installing it is a very precise business. It has to be in just the right position to turn the massive propeller. 4 months later, the hull is complete, and the massive propeller is in position. It's all hands on deck to build the deck house, where crew will live for months at a time. There will be an incredible 10 miles of piping on this ship. Here, workers weld and bolt them to the deck grand blocks. It's an elaborate maze with an impressive master plan. They connect these pipes to the series of tanks in the hull so they can be used to load and unload cargo. Meanwhile, inside the hull, those cargo tanks are coming together. On the very bottom, the crew builds a network of heating coils. They'll be used to heat crude oil to a more fluid form so it can be pumped out of the tanks. Other workers grind welded seams on the ship's outer skin. This evens the surface for painting. The paint is an epoxy blend that resists corrosion in salt water. They apply it in 3 or 4 layers and measure its thickness with a special ultrasonic gauge. In total, they spray more than 38,000 gallons of paint on this tanker. In this time-lapse video, our tanker comes together like toy building blocks in a matter of seconds. But as you've just learned, this is a complex job. It actually takes 16 months. A couple more months of testing, and this tanker should be good for the long haul. At first glance, a racing wheel doesn't look much different than a standard wheel. But look a little closer. There are subtle differences in the angles and contours that set it apart. They give it the strength to handle the extreme forces of racing and to corner well at high speed, which should have them cheering in the stands. The driver will get the trophy and the credit, but a good set of wheels is behind every win. They start with high-strength, low-alloy steel, which is a very stable material. The first of a series of die presses gives the center disc a concave profile and forms lug holes. The next press punches a hole for the hub and others called windows. Windows help cool the brakes while maintaining strength where needed. They stamp rings around the windows. This is called coining. The rings give the windows a nicer look, and the action compresses the steel to further strengthen the part. The next press is critical. It forces the disc into a bowl shape and gives it precise dimensions to accommodate brakes. The specific angles also reinforce the part. It has taken a lot of punching and pressing, but the center disc of this racing wheel has really taken shape. A smaller press now punches out the lug holes that were outlined earlier. These holes will allow the wheel to be mounted to a vehicle. Then the center disc goes for a spin as a series of tools trim it. The part is now complete. To make the rim, a machine unwinds coiled steel and rollers iron out the curl. A mechanical arm maintains slack as the flattened steel goes under the knife. The blade, called a shearer, cuts the steel to length and stamps product information onto it in one swoop. An operator now winds the steel between 3 rollers to twist it into a band. He then places the band into the jaws of a welder, which fuses the 2 ends together. He then slides the band into a machine that scrapes off excess material from the weld. It's still warm, so it can be easily removed. Now, the band comes under some serious pressure as a machine forces it around dies at both ends to create flares. This rack transfers the rim to a series of rollers, which shape its inner ledge. This part of the rim is called the bead seat, and it will be attached to the bead wall of the tire. They trim the rim to make the edges neater. This finishes off the part. They nestle the center disc loosely in the rim. As the rim spins, they heat the outside with a torch. This causes the steel to expand, and the center disc drops further into the rim. As the rim cools, it contracts, shrinking to the center part. The 2 parts are now interconnected, and a welding job makes the bond permanent. A worker drills threaded holes onto the wheel to attach valve stems. As it exits, the drill turns in reverse so it doesn't wreck the threads. After a fresh coat of paint, they apply a thread locking adhesive to the valve stems and screw them into the holes. The valves will be used to add air to the tires. The wheel rotates as a small roller paints a stripe onto the rim for accent. Then a press stamps a number onto it to identify this wheel in the event of a problem. And now this wheel is on a fast track to the finish line.